All right, so if we want to maximize something, our goal is to find a formula for what we want to maximize it. So volume is length times width times height, so x times q minus x. So x squared times q minus 4x. Distributing that, that's qx squared minus 4x cubed. Maximums and minimums will happen when when the derivative is 0. So taking a derivative, remember that q is just a constant. Treat it just like you would any number, like a 5 or something. So when you take the derivative, you'll multiply 2 times q and just get 2q x, and then minus 12x squared. So maxes and mins will happen when this equals 0. You've got a quadratic, so anytime you're trying to solve an equation with a power that's bigger than 1, your goal is to try to set it equal to 0 and factor it. So I can factor out a 2x from both of these, leaving me with q minus 6x equaling 0. And that's nice because if this times this equals 0, then one of these factors must equal 0. That's the only way to make a 0. So either 2x will equal 0 or q minus 6x equals 0. So x will equal 0. That sounds like a minimum. And or minus 6x will equal minus q. So dividing by 6, x will be q over 6. And we see that as our answer A. Technically, we should check to see that it is a maximum and not a minimum. And you could do that by setting up a sign line with 0 and q over 6. If you plug in anything bigger than q over 6 into here, you will get something negative. Let's see, so if you do q minus 6 times q over 6, something bigger than q over 6, so like 10q over 6. So q minus 10q will be negative. This will be positive. So you're going negative, and if you plug in anything between 0 and q over 6, you'll get positive, and then negative, so up and down. It is a maximum. Yeah, I get a little lazy. If you tend to find something that tends to be the answer you want, you can maximize this volume so that when you find it should make sense. Cool, that's it.